Next up, we have a panel discussion. It's titled The Road to Quantum Commercialization, Scaling for Industry Adoption. And I want to invite our moderator and panelists to come up. Anastasia Martinkova is going to be the moderator. She's the CEO and founder at One Quark Media. Martin Yates is Executive Office, Government Technology Office at Presight G42. James Grieve is Senior Director of Quantum Communications at TII, Technology Innovation Institute. Mark Luo, CEO and co-founder of Quantum Brilliance. And Dr. Travis Ramsay, Senior Specialist at ADNOC. No, you're good, you're good. Lady and gentlemen, please come to the stage. Let's give them a hand.
All right, good morning, everyone. Very excited to see you all here for day 3 of this conference. And we have a great panel today talking about commercialization. Because most of us have been working in quantum for a very long time and have seen the industry evolve. And so now the question is, how do we bring this technology into the hands of everyone? And how do we teach them how to use quantum technologies? So I'm Anastasia Martinkova. I've been in quantum technologies for over 15 years now, working on quantum telecom, superconducting qubits, and software. So I've been all up and down the stack, and now working on some super cool stuff. So I'll talk to some of you about that. And really happy to have folks on the panel today to talk more about this technology. So if everyone could introduce themselves and give a short bio.
I guess I'll start. Good morning, everyone. My name is Martin Yates. I work for an organization called Presight. It's a Group 42 organization, and we look at artificial intelligence, smart cities, energy, and many of the different public sectors. And of course, we're very focused on how we apply artificial intelligence to the variety of use cases as we scale internationally.
Good morning, everyone. My name is Mark. I'm the CEO of Quantum Brilliance. We're from a company that uses synthetic diamond to make mass deployable quantum technology. Synthetic diamond is very unique because it's able to be utilized to build room temperature, small compact quantum systems for both quantum sensing, quantum computing, and also AWS is using it for quantum communications as well.
Good morning, everyone. My name is Travis. I am a senior specialist with the Abu Dhabi National Oil Company, ADNOC. I have been with ADNOC now for nearly 4 years, working in what's called group technology. We are tasked with evaluating and de-risking all sorts of technologies with the ultimate aim of deploying those technologies once proven successful. My experience is rather vast, covering earth science, as well as degrees in physics and geology, and a doctorate in computational physics. And that simply gets used in the context of the work at ADNOC to really look to scale technologies for our business.
Good morning, everyone. My name is James. I'm the Senior Director for Quantum Communications at the Technology Innovation Institute in Abu Dhabi. So we've been working for about 4.5 years now. My team build primarily quantum key distribution systems, but also quantum random number generators and sort of adjacent technologies.
All right, so the first question I want to ask today is, there's been a lot of news even this morning in the last couple weeks in the quantum space. So announcements like IBM's Progress, Microsoft Majorana's, hundreds of millions of dollars being raised, leadership shakeups. There's been a lot going on in the quantum space. So, but the question is, when are we actually going to get to that commercial advantage? So the question that I get is, how do these milestones actually impact the race towards commercial scalability? And where do you see the biggest gaps still remaining? And what do these milestones actually mean for an end user or a customer that is looking to bring quantum into their business?
So I'll start then. That's a great question. You know, it's a bit, I think you could ask ChatGPT and all the different versions and get different answers, right? And I think that's what we're all here for today, is that there really isn't any definitive answer in so many ways. I think for the average user, quantum, for the average enterprise, quantum feels, from the board level, feels very, very far away. And if you look at investments and where they come from, so, to us, I mean, I'm regularly holding conversations around quantum, and I talk about artificial intelligence, talk about data management, and these are all subjects that people can really understand and put milestones against, we can put projects against. For quantum, is definitely much more specialist, tends to be much more on the CISO side, the security officer's side of the conversation, rather than the value that you can extract from quantum. So I think depending on who you speak to, you get different milestones, right? And that's really the main part. And some people have completely closed ears, and other people are like, please tell me more, we need to protect our organization. And people are racing to that, well, when will I get my money back if I invest in who's got the best technology? And there are so many X factors that all multiply themselves out. I literally will take each enterprise on a case-by-case basis and try to map into their roadmap what makes sense, because it's just moving too quick, as you've seen over the last few days, and you've got AI matching to that as well, which is also going at the speed of light. So it moves very quick. And our advice is just let's be cautious and careful about how we invest and set the milestones and the roadmaps, but also get the board involved in those conversations. At least they have an understanding of what might need to happen and what might need to be invested in.
I agree with that. Caution is definitely needed. From my perspective, I think the two main barriers, the first one is the hardware itself is still quite immature. There is still quite a lot of technical challenges that needs to be overcome, and there is almost a imbalance between expectation and where the hardware physically is at. But that can be overcome. But the second barrier I actually see is application discovery. So when you actually look at quantum technology, there's more than quantum computing. There is a lot of up-and-coming quantum computing companies that's doing algorithm discovery. We've seen a couple like Kipu Quantum sitting at the front. But I would also say there's more near-term quantum hardware that is unexploited. And one area is quantum sensing. In the previous panel, in the previous keynote, we saw quantum communications is quite mature. I often feel that quantum computing is sort of the poster child of quantum technology. But the reality is there is these really mature quantum hardware platforms that people don't understand, but when you actually start to apply it into application engineering, the opportunities are endless, and there's much near-term commercialization opportunities other than fault-tolerant quantum computing.
So what I would preface to say here is that from a technology standpoint, it's all greatly interesting, but at the end of the day, there's still an address to management that I have to go through in terms of evaluating technology and going through that proposal. And so what the challenge that comes out many times is where and how is this technology being able to benefit our business? And so when we have a question that comes up in this regard, it's simply going to be, about that business case. Is it thorough? Is that technology applicable at this time, if not when? So being able to get a gist of, those timescales. For us, as ADNOC, we recently initiated a study with TII that looks at quantum sensing and its application to carbon storage, as well as looking at battery lifetime prediction. So using quantum sensing tools in order to measure the magnetic fields associated with these processes so we can better understand them for the sake of our operations. So we saw this as an opportunity because the technology was in a state where we could do that evaluation. And that we saw that there was a potential upside. Now, there are other areas of the quantum verticals where we're interested and where we're looking. Certainly in communications, we need to, of course, be able to protect our critical infrastructure, ensure that the data that we have, remains secured, and also when we go to work with partners and collaborators, that we are able to share data appropriately without having that concern for eavesdropping and from bad actors. So that's certainly a space where we are looking. And then lastly, looking at the computing space, because while of course it is there, and there's a tremendous amount of potential, we see that there are cases where there's applicability in optimization and uncertainty and dealing with stochastic types of problems. However, we have significant challenges when it comes to modeling partial differential equations, when it comes to modeling very large amounts of data. So there are very highly nonlinear problems, but there's also a tremendous amount of data, and so we still have to assess the technology within that framework to ensure that we can actually achieve something that's really going to be beneficial for us. So I would like to say that there is progress, but there's still a disconnect and disjoint that we still have to work through, and that's where de-risking really comes in for us.
Okay, I think these guys pretty much covered it. I would have said that in terms of generating value today, computing, of course, is the poster child, as we said, right? But it's the furthest away, and of course my area is quantum communications, and I think from the previous talk it was pretty clear from what Simon was telling us that QKD is already delivering value, already useful. So I think you could sort of wrap the whole community up and say, look, it's all right if we have an enormous amount of effort going into quantum computing, but it's nice to have some attention paid to these nearer term applications in sensing and communications where we can start to show people that this new wave of quantum technologies, not forgetting that existing quantum technologies that are already all around us, right? But this kind of new wave of things that exploit entanglement and superposition and so on actually can do useful stuff even before we get anywhere near a large fault-tolerant quantum computer,
Great. So there's been a lot of hype over these long-term applications, but I'm glad we talked about these near-term because there is a lot of value that quantum can bring even today. But one of the things that has been interesting to me, QIS actually put out a report, I believe in December, talking to the end users and saying, and surveying them, why aren't they utilizing quantum technologies today? What is the roadblock? And one of the things was infrastructure bottlenecks. So how does the enterprise client actually handle the implementation with the existing HPC structure? So what are those critical infrastructure challenges in hardware, software, or even the talent space that must be tackled before the quantum solutions can actually be integrated into an enterprise or a commercial client?
Yeah, so that's the million-dollar question, I guess, in the sense that, preparation, are people really ready for this? What does it mean to the business? And so, it really starts with completely modeling, looking and understanding and modeling the business and saying, how does this affect our business model, right? And the fact is what kind of infrastructures, what should we be using, and what kind of partnerships, because at the end of the day, you can never do these things alone. It is always going to be about one or more partnerships. So do you align yourself up with a Microsoft strategy or an IBM strategy or D-Wave strategy? There's just so many possibilities, and it's almost like that decision of, which we've seen that ChatGPT came out, but now you have the Grok, now you have, DeepSeek, you have all these different choices. So you say to yourself, so where do I align myself? Where do I start my journey? And this seems to be the biggest sort of question for us right now on the table, and how do we create those advisories, and how do we do that education, and in what sectors of education, where do we splice out in each individual business? And I talked a little bit earlier that, by prioritization, I think the scary thing that everyone talks about is the security, right? Because that's the first thing that, and obviously there are different stories, but all world encryptions will be entirely broken anything between now and the next 20 years. And you can try and sort of put your thumb on where you think it is. And then when you see announcements where you hear things like a million qubits, you go, oh my goodness, I better start doing my security a bit faster. But then you have to dig into the reality and see where it is. And that's that part of preparation within an organization that we need to look and examine across the different enterprises, and particularly governments too, and in the defense industries.
Yeah, that's adding on to that infrastructure integration piece really depends on which partner you pick and how you select that partnership. Our experience at Quantum Brilliance is during COVID in 2021, we were a bit crazy. We decided to build a quantum computer remotely across, different people's houses. We were the first company, I would say, to install a room temperature quantum computer inside a supercomputing center. This year, we're installing 3 quantum computers at Oak Ridge National Labs in US in Tennessee, and we just shipped one to Germany last year. Where our landscape has started to change, though, is we think the supercomputing center market from an integration perspective is too competitive, and the learnings we've had is pretty much completed now, which is we understand the software and hardware integration. What we're now exploring is actually data center integration. So we're already starting to work with 3 different data centers globally to actually look at what physical on-premise integration looks like and how does it really match the business model. The business model of data center is becoming very competitive and really interesting, as you would know, G42. So a good example here is in Australia, we have a company called Goodman Group. The company is a listed real estate investment trust that focuses on industrial warehouse REITs. And within the past 12 months, they've decided to change their model into a cloud service provider as a data center infrastructure provider. And they're actually now looking at installing advanced compute hardware that is non-traditional hardware in order to remain competitive and ahead of the curve to earn a higher yield. And so when we look at that player, that becomes a very unique player to integrate with because the way they think about compute hardware infrastructure integration is just completely different.
So I would start off with a point by saying common language is going to be a first bottleneck to integration point. So for us, it's going to be KPIs, right? So, every company is going to have their KPIs. And so basically, how is your technology going to impact, my KPI for this year? I'm required to have these deliverables, and so if, in order for me to take this technology into consideration, before I look at, how it can be integrated into my system, I have to know, what can I expect, for this to be able to help me out this year. I can start looking at, later on, at a time thereafter, but up front, I need to know what's going to go on this year. In terms of what's going on, at present, ADNOC just recently completed the largest 3D seismic acquisition in the world, so 85,000 kilometers square of seismic data that's been acquired. There's a significant need for processing there, and so from the get-go, you're not able to, say, process an entire seismic volume using quantum computing, but things like interpretation, you'd be able to at least help out with and then see, over some period of time where you can go before you can start looking at how does that, integrate with existing capabilities. We are a very large organization. We have well-established workflows. We're not necessarily looking to have a complete system overrun. We are looking to see how we can adapt with what we have. And again, going back to the business case, we'd have to, if we're going to consider a major scale change, we have to understand, what is that cost going to be, not only in terms of upfront funding, but also how is it going to impact our individual employees as they conduct work in their day-to-day lives.
That's a good points. Again, it's interesting being on the last of the row here because I get to kind of pick which of these points I'm going to agree with, right? But I think the question was about infrastructure, right? And what are the challenges to adoption there? And I think when it comes to quantum computing, there's a sort of simple answer there, which is like, yeah, we do some kind of cloud access. So you locate your very expensive, very exotic hardware in one place, and you let lots of people use it together, and then you sort of spread the cost across many customers, and you kind of reduce the you simplify the cost-benefit analysis by reducing the cost of access, right? So that sounds good. And then when it comes to sensing and communications technologies, it's not as trivial, right? I think there's a direct analogy with communications to the data centers because, of course, if you can run QKD networks between different data centers, then you can somehow, again, spread the investment, spread the cost across multiple customers that exist in both data centers, right? But this isn't trivial, right? You either have to have someone who's willing to front the cost and pay for all this, betting that there will be customers who are happy to somehow share the reimbursement, right? Or you have to somehow bring together a coalition of different customers who all, agree in principle to use it. So I think it comes back to this kind of weird social engineering question where you have to somehow build a consensus that a group of people want to do something. And this seems to have happened sort of automatically in quantum computing. In sensing, I have no idea how you do this. And in communications, it looks like we can copy computing, but it's difficult. I mean, in places like in Singapore, the Singtel and the SPTel, there's two networks there. Both are doing a data center interconnect, but there's not a lot of information about how many customers they've actually managed to rope into these networks, right? So it's still a kind of open question whether it's going to be successful or not, right? Even if it looks pretty obvious, you know?
Yeah, I definitely want to echo some of this interesting shift, at least I've seen. So it used to be 10 years ago, there was very few options for the quantum hardware side, right? So a customer would come and go, well, we've heard this team has a quantum computer, that's what we're going to use. And now things are shifting. So I've been very heartened to see the fact that a lot of companies are putting out business case studies with actual applications and putting out even open source information out there for allowing the business customer to even have that mindset of understanding where they could even go. So I know one of the mistakes I made a decade ago, the team would go to a customer and say, give us a problem that a quantum computer can solve in your industry. They don't have that framework in their head yet of what problems could even be accelerated by quantum machines, right? So we've kind of gone over the hump a little bit, but these case studies help people understand how we can actually map those problems, those business problems to particular use cases and then to the particular hardware. So something we've also seen over the last couple of years is seeing that certain algorithms can be optimized for different hardware systems. And so it feels like we're flipping now in this infrastructure of looking at the problem first and then picking the frameworks and drilling down and then testing across different hardware and software stacks to really optimize and have true business cases. But in the end, I also want to echo what you all said about the ROI. Right, so there's been a lot of early believers in the industry about quantum computing. They put a lot of money in and haven't expected. I was on a panel at Q2B with the Airbus BMW folks, and Airbus says, 2035 for us is like tomorrow. So they don't really need to care about ROI. Other customers demand it very quickly. So what metrics and frameworks should these enterprises use to evaluate the quantum's commercial viability? And how do we ensure that they really stay confident over these really long R&D cycles?
Yeah, again, this is going to come back to an understanding, and every organization has a kind of a unique fingerprint in terms of how they approach things. So, if you look at the classic organization between CISO, CTO, Chief Products Officer, they're going to have different views and opinions of how to move forward. And so really I guess that's the main challenge in terms of how do you get that framework out of people? What does a framework even look like? And I mentioned earlier about the education because, as a CTO, CSO, CPO, you're kind of have so many challenges of today. Let's be honest, it's make money today because the world is becoming very interesting. Everything changes much faster than it did 10 years before, and it changes faster than it did 10 years before that. So really it's a question of, what kind of framework should we look at? And I suppose there's a classic enterprise framework that's driven by CTOs is still valid, right? Whether you do a COBIT type kind of assessment, where am I on a maturity level? How am I embracing quantum? What does it mean? Is it security first? Is it because I have a use case in medical? Is it because I have a use case in climate change? So it's all going to be essentially driven by those. And for us, I simply sit down and say, whatever framework works for you, as long as we have the key criteria in that you need to make the right business decision, let's make that work. So I don't necessarily have a specific one direction, although I'm quite often in favor of a COBIT framework for assessing maturity of organizations. At least it standardizes itself across the world. But there are many other frameworks. But I definitely, if someone challenged me right now, write a white paper or a roadmap for this organization, I'd probably use something like a COBIT kind of framework to assess and develop that maturity needed across the organization to make it happen. And it's all going to be about what I call the value. It has to make sense in terms of dollars and cents, so to speak.
As a startup within the company, we're always making that decision because as a startup, your resources are limited and you have to be very deliberate about the product market fit that you pick. So the business decision tree process we go through is we decide whether the application, the actual end application, and even for quantum computing, we go through a process of actually identifying exactly what does this application actually do. Then we ask ourselves two questions. The first question is is this an incremental improvement by how much percent, or is this a transformational impact? We prioritize application that has transformational impact because it just can't be done with any other classical or quantum hardware. Then the second screen criteria we have is how big is the volume? And if it's a very high volume application, you just double down. And I think the reason why at Quantum Brilliance in sensing, we're very excited about it is because the volume is so high. And when you actually come to high volume, you can then start to look at manufacturable yield, you can look at market impact, and the numbers all of a sudden make sense. You're not relying on management consulting numbers, no offense to management consultants here, but you're actually relying on bottom-up analysis to actually see, does this market make sense? And then you can make a business decision.
I would start by saying what value can be generated, how much can I save, and what's the potential for scalability. Really looking to see, what we can get back out of it. In terms of potential for scalability, I wouldn't look at it as just simply a rather open term, but simply looking, if we're address the sensing side, are the tools, are the methods that we're looking at, so say we're looking at magnetic field sensing, is it something that's applicable to, say, our oil and gas operations, say for monitoring? Is it also applicable to our carbon sequestration activities, so be it in saline aquifers or be it, in mineralizing rock? So there's multiple sets of applications that exist, and we want to be able to address technologies that can be really plugged into various different niches and really scaled throughout the organization. So, we see the same thing in computing, where, it's not simply having a challenge with optimization, although we have, many of those, but we do have additional challenges as well, where we need to be able to scale the technology adequately. So being able to solve, disparate sets of mathematical challenges in addition to optimization. So again, going back to those PDEs and looking at hybrid solutions, what will be the cost of, considering such a hybrid solution? And what is it that we're going to get back as an organization for having that technology deployed?
Okay. So I think maybe what kind of unites the sensing, communications, and computing here is that if you want to try and actually put a number on the kind of value you get out of any one of these technologies, it's not going to be from that technology in isolation. It'll be part of some larger package, some larger kind of infrastructural solution. I guess you could pick on sensing or something. Like, let's say you could sense something in an oil field or something, right? Like you're monitoring a pipeline or something like this, right? That doesn't automatically, unless you're the guy selling the sensors, that doesn't automatically generate value, right? You have to have it as part of a larger kind of structure, right? And in communications, this is particularly clear because we're doing security. So you're kind of insulating people against a future risk. So you're asking companies and you're asking entities to spend money now against a hypothetical threat. At some point, they're going to lose some money, right? So it's very difficult to make an ROI kind of argument there, at least not with concrete figures, right? So what I've been more interested in recently, and I think this is directly relevant to the sensing side as well, maybe not so much the computer, is like how can implementing quantum communications or quantum sensing like change your operating procedures today in a way that you actually can say, cool, that would save money, right? So in particular with, say, quantum key distribution, I pick on like a government sector thing, maybe there are security protocols, there are certain classes of conversation, or in industry, maybe there are certain types of information that cannot be digitally transferred between sites because you have a security protocol in place saying, look, that's too sensitive, we can't trust the infrastructure, right? And maybe with something like QKD, or with a package combining QKD with post-quantum cryptography and classical cryptography, like a hybrid solution, you could say, look, I've now raised the security guarantees to the point where we should revisit these arguments and maybe we can do this stuff remotely. And then if that saves you money on couriering or meeting in person or whatever, then you can come back to your operations and say, look, we would save a whole bunch of budget from operations by deploying this right now. And I think this is maybe this is just preaching to the choir and this is super obvious, right? But that's got to be the kind of package which you use to make an honest statement about return on investment. You can't just say, this guarantees you an awesome new product or something. It's not true,
Definitely. So we've talked a lot about the raw chip and the hardware level, but we need a lot of other stuff to make the quantum computers work. So where do we currently see the biggest missing pieces in the quantum tech stack Particularly, I'm interested in bridging the layers between that raw metal and the higher level end user applications. So, for example, the under-celebrated components, the middleware, the cryogenics, all these still need to be developed in parallel with the quantum systems to get them to actually deployed on-prem with a customer or in a data center. And how can we actually accelerate the progress in those areas?
Yeah, again, so acceleration comes from people's knowledge in the sense, and so what knowledge do we have? And so that's absolutely cool. So for me, I think the thing that is typically missing, and when I look into development organizations, is, what are the right tool sets that you use? What is the best practices? And I think a lot of that's still emerging. You see sort of like from IBM and Google, you see a lot of early development, like the SDK kits. But again, how many people will go out there and start working with those SDKs and start understanding where do I get my bang for the buck, in terms of return on investment, in giving these developers this time and then access to the system. So, it's a very, very difficult area to do. So really, for us, it's really about doing that we don't all have a quantum computer yet, but we can have access to them. But of course, without being able to have an understanding of what use cases we're developing and having the software development kits, we're always at a bit of a loss. And so for us, it's like, who do you partner with? Whose SDK do you use? How do I make it as agnostic as possible? Because you don't want to lock yourself necessarily in to any one, visions or partner of the future. You want to have that agnostic approach, and it's really not easy. And I think definitely in the next 1 to 2 years, it's going to be much more clearer than it is today.
Definitely, that makes a lot of sense, because even if you're comparing between SDKs, say some SDKs may be better for education purposes in the organization, other may be better for production or have more integration. So you also have to balance, you may actually have multiple in parallel to get where you need to go.
So in terms of the value chain, it's matured so much that, for example, Quantum Machines just raised 170 mil, and a company like Quantum Machines didn't really exist before, but I think there was a really interesting study that actually showed the cost of quantum computing hardware development has actually fallen by 75%, as opposed to doing everything internally yourself. One of the areas that we're working on Quantum Brilliance is we use synthetic diamond to build quantum technology. What has really shocked us in the past 3 years is globally there's at least 12 large companies that are using synthetic diamond within the semiconductor value chain. And that has meant that we are already starting to work with a couple of semiconductor companies on how our technological build approach is also applicable for power electronic device build. And so we're really looking forward to working within the entire value chain, because quantum technology is such a complicated hardware. The only way to win is to do it together.
I would just simply say, and rather laconically so, being technology agnostic would simply benefit us, because as a business, we're able to plug and play as easily as we can, and it helps us with adapting as new needs come up and as we need to move forward.
So in terms of components for quantum computing, I think when it comes to scaling, most of the architectures look to me like they're going to sort of hit a limit at a few hundred qubits, right, per node, right? So really, if we want to scale to a very large quantum computer, we're going to have to connect together multiple different processing cores. So it's about photonic interconnects, right? And what it looks, I mean, speaking as the photonics guy, to me, it looks kind of like it's very hard. I can think of 1 or 2 companies that are focusing on just that, but only 1 or 2, right? And they're quite small. So this is one of those enabling technologies that will help many different platforms to scale. But it's not obvious how you fund that research by itself, right? So that should obviously be funded by a quantum computing company. But most of the large quantum computing companies are still very busy trying to scale the individual nodes, and maybe don't have a massive in-house effort with relevant expertise working on these interconnects, right? So I think that might be a bottleneck coming in the future when, for example, a superconducting company realizes that they're going to have to do photonic transduction from the microwave domain, but they only really accept that fact once they've completely run out of runway on the individual chips, right? I'm just making this one up, right? But I think that's interesting. So it's these enabling technologies which should be best addressed by, domain experts in those areas who are current, but because of the lack of attention to that area, or the lack of, I guess, lack of hype around that area, it's not obvious how you build a compelling argument to invest in that right now, especially if you have like near-term ROI claims, because again, if you're investing in one of these companies that just does interconnects, they're not really useful until there are larger quantum computers. So, and as we all know, it's very hard to say when that's going to happen. So I don't know how we solve that, apart from just to wait for it to become a pressing concern, right?
Anastasia, we've come to the end. I hate to say your time is up.
Perfect.
Can you go to closing comments so we can try to
Definitely.
get closer to schedule?
Definitely.
Thank
So
you.
to close out, I just wanted to ask in one sentence, what's your best advice for an organization preparing to invest in quantum over the next 5 years?
Oh gosh, be really, really aware the comet is coming, and you still have time to be able to shoot it down or get it out of the way. But don't ignore it. It is coming, and it will be a huge difference. That wasn't one sentence; it was several, but.
Close enough.
The quote I use is actually from this conference. There was a lady, Dr. Claudio, from the family office here. She said the cost of doing nothing was too big. And so you have to do something because quantum's coming.
Cost-conscious de-risking based on the potential to scale. Keep it simple.
I would say it's trying to avoid like decision paralysis, right? So particularly when it comes to security, you can attack different layers in parallel. So just use what's available now, and don't stress too much about what's the perfect answer, right?
All right. Thank you so much to the panelists today and to everyone for coming, and enjoy the rest of the conference.
All right. Thank you, Anastasia. Thank you, team. Well done. Do you want a picture? Is this the moment for the photographers to gather? I think that's kind of a cool protocol. You want to stand in the middle here, and they'll take a picture of this distinguished group. Yeah, put Anastasia in the middle before we move on. Seize the moment. Assume the position.